Welcome to today's webinar, Sustainable Fleet Technology Series, using telematics data analytics to plan for fleet electrification. Before I hand things over to our presenters, I'd like to quickly review a few housekeeping items. This session is being recorded. All participants are muted during the presentation to minimize background noise. We do encourage you to ask questions and share comments using the chat feature, which you can find in your Zoom toolbar. If you experience any technical issues, please reach out to the NAFA team through the chat, and we'll be happy to assist. And now it's my pleasure to turn things over to Ulrich Lunsford.
Thank you, Larissa. My name is Alaric Lunsford, and I'm a senior clean transportation specialist at the North Carolina Clean Energy Technology Center. And today's webinar is going to be about using telematics data analytics to plan for fleet electrification. A little bit about the North Carolina Clean Energy Technology Center. We are a public service institution that works with public entities, governments, businesses, utilities, and citizens as related to developing and adopting clean energy technologies that include the transportation sector. Through our programs and activities, we try to promote the development and use of clean energy in ways that stimulate a sustainable economy. And we obviously partner with NAFA on a number of different initiatives, this webinar being first and foremost for individuals who manage vehicular fleets and mobility responsibilities to expand access with this webinar series. Go to the next slide. NAFA has upcoming training on information management for fleet and mobility professionals, which is an online certificate program, June the 1st through the 3rd. You can register by clicking on that QR code uh, that should take you to the URL. Next up, we have our Sustainable Fleet Technology Conference and Expo that's going to be held at the Durham Convention Center, Durham, North Carolina, August the 25th through the 26th, or I'm sorry, 27th. And this is a bit of a milestone for us. This is our 10th uh, conference that is culminating, obviously, with some of the in-person webinars that we did during the pandemic years. But this is our 10th year. We started out, or Durham has been our home base for the conference for many number of years. We're very excited in terms of it'll be a great conference. We have very good, interesting keynotes, and the conference is basically is tailored upon looking at the latest and greatest with industry trends from OEM perspective, seeing what they actually have in product development, as well as bringing clean cities and communities, public and private fleets, but mainly public fleets, as well as utilities, electric cooperatives underneath one umbrella to be able to see what people are doing in terms of helping organizations out with achieving their sustainability goals, as well as attending different breakout sessions that focuses on planning for funding, as well as basically looking at some charging best practices and vehicle technologies to kind of like round it out. Looking forward to that conference in August, and you all are more than welcome to go on to sustainablefleetexpo.com to actually register and join us. And as I was mentioning, 12 breakout sessions, over 70 speakers, and over 40 exhibitors and vendors. And the information for that is below. So now getting on to the webinar. Today we have some excellent speakers. Um, First, we have Jared Walker, who's a senior specialist in EV product analytics for Swatch Labs, that is a WEX company. Then followed by him, you'll hear the voice of Katie Fletcher, sustainability program analyst for Denver Water. And last but not least, we have Ronald Worth, Fleet Advanced Planning and Sustainability Manager, County of Sacramento, Fleet Services Division. So with with Jared, a little bit about Jared. Jared spent nearly 2 decades in the automotive fleet experience, so he has a wealth of knowledge going all the way back to 2007, with his expertise spanning in comprehensive auto market dynamics, strategic maintenance management, as well as full life cycle cost reduction. And since 2018, Jared has worked closely with hundreds of cross-sector fleets that includes specialized equipment with complex needs to guide their procurement strategies. Um, and he likes to take a data-driven, fuel-agnostic approach that leverages analytics into a deep understanding of advanced automotive financing strategies to pinpoint exactly where the replacement of internal combustion engine vehicles with EVs makes the most financial sense for organizations. Jared, I'm going to go ahead and let you kick things off and take it from here. The floor is yours.
Fantastic. Thanks, Ari. You just pop to the next slide. All right. Hello, everyone. We'll just, I guess, go ahead and dive right into it. So, as Ulrich said, my name is Jared Walker, and I joined Swatch Labs 4 years ago. A little bit about us. So, we were actually founded in 2017. Wisely, I would say, acquired by WEX in May of 2024. Um, in the almost 20 years that I've been in the fleet industry, I've seen a lot of change. And really one of the biggest changes was the telematics piece, which is exactly what we're talking about today. Certainly there were telematics devices back in the day. And one of the things that became very clear, just that sort of as an industry, is everybody was able to recognize, like, hey, this stuff is really powerful. We've got all of this data and it's very precise. But the challenge is, what do we do with all of this? It's a lot to sort through, thousands and thousands and thousands of lines of data for one individual vehicle. And so that's where Swatch Labs comes in. And so again, founded in 2017 to answer that question, and to really help organizations and customers and fleets that we're working with to leverage that power of the data through our analytics tools, which we'll talk a little bit about today. And just one big thing to kind of call out is that we are a neutral, we're fuel agnostic, we're a neutral advisor, we're manufacturer agnostic. Really, we're just interested in the data and helping organizations that we're working with and customers to best leverage that data to help them to develop strategies based on exactly how those vehicles are operating and their unique characteristics. And next slide, please. So why I see the telematics being so powerful is probably pretty similar to most of the people or everybody that's on this call. Is it's so powerful to be able to create a digital twin. And so that's essentially what we're doing when we're ingesting the telematics data. We're observing how an individual vehicle behaves minute by minute, from ignition on to ignition off, where it's driving, how it's driving, where it's parking, how long it's parking, what is it doing, all of these different aspects of how a vehicle operates day to day is what we're creating with this digital twin, which we can then map onto other fuel types, other vehicles, and we can fold in different parameters. And so by creating this digital twin based on the exact data and the exact information of how that vehicle is driving, we can then continue to build on that. But we have to have that data in there first in order to do those different scenarios. Once we analyze all that data, then that fuels the operational confidence of the organization that we're working with. And it allows them to really fine tune a strategy moving forward that's going to make the most sense operationally, from a cost standpoint, from an emission standpoint, market dynamics, all of these different things feed into that, and we're de-risking. So we're reducing the risk that can sometimes come about when we're deciding to make a big change or make a big investment. And then critically, the online calculators and using averages and things like that all has its place. But one of the most powerful things that we're able to do with the data that we collect and that we analyze is we're then also able to fold in specific locations and understand and pass along information to the customers that we're working with, to the fleets we're working with exactly how many ports you need based on exactly how your vehicles are operating, what kind of vehicles, what kind of power draw is required, and what that would look like from a location standpoint as well. So where to put the chargers, what kind of chargers, and there's a lot of cost savings involved in that as well. So I just kind of wanted to set the table with that. There's so much information that we can capture. We just have to know how to use it and do it in the right way. Next slide, please. So this is kind of an overview. These are some of the applications that we have developed as an organization using the telematics data to support really optimization, fleet optimization. So that first one there, Easy EV, that's really focused on how the vehicles are operating. That's really our kind of vehicle-centric app. And so usually when I'm working with a fleet, that's really where we start, is looking at what vehicles make the most sense and why, or what vehicles don't make sense to transition to electric and why. We can then take that information, analyze it a lot further, and then that feeds into EasyIO, which stands for infrastructure optimization. And so once we have sort of a profile of all of the different vehicles and how they're operating, then we can understand how much energy is going to be required to avoid any kind of operational challenges, and where to place those chargers and how many chargers you need. For fleets that have already a mixed fuel fleet, where you've got a couple different types of fuel sources or propulsion sources in the fleet for the different vehicles, we have Ion EV. And so what's neat about that, and I'll get into a little bit more later, but we can observe how those vehicles are operating. So if we, say, 3 years ago, made a lot of recommendations, worked with the fleet, analyzed all of their vehicles, and we come up with a projected cost savings, TCO, from transitioning specific vehicles to electric, we have Ion EV to make sure that we're staying on track. Sometimes it happens where maybe a fleet will get a bunch of plug-in hybrids, and then, we come to find out, well, we're not really hitting the cost savings that we originally projected. And that's because maybe we can find out that maybe we find out that they're not being plugged in, so that end users are just driving them like a normal gas car. And that's just negating all of the benefits of having that PHEV. In fact, now you're just driving around with two powertrains and you're not using one. So there's a lot to that. Also, proximity to charging stations and reimbursements and things like that, how those vehicles are actually being operated to continue to refine and improve on the performance of the fleet. And then Emit is a really easy way to understand, track, and report on the emissions, the changes in emissions across the fleet. Or you can drill down into one specific vehicle and look at what that looks like. So if you were to bring in 10 EVs, say, with this tool, you're able to log in and you can see what that impact looks like from an emissions standpoint. And that's both carbon emissions, but then also particulate matter as well, which can oftentimes be overlooked, and very important, especially for our OTR fleets that we're working with, where that reporting is required. Next slide, please. So I really like this graphic because it just kind of displays what we all know, which is, Manufacturer might put out a statement that a specific model is capable of getting 230-mile range. Maybe in perfect conditions, maybe if it's 75 degrees and it's flat and the driver's had a full night's sleep and is not, taken off too quick from a stoplight, maybe you could get that. But we just very rarely see the advertised range being as accurate. Maybe we're not taking into account all of the variability that naturally any vehicle, any driver, any fleet is having to work with. And so, what going back to the idea of that digital twin, what we're first identifying is exactly how much energy is a specific vehicle requiring minute by minute. And it could be maybe they're going uphill, maybe they're pulling a trailer. There could be an auxiliary load where maybe it's a large vehicle and we're running a PTO, refrigeration. All of these different factors come into play. And actually, this is really just these are just kind of a few high level examples. There's over 100 different variables that we're pulling into this, and we're building that profile based on exactly how your fleet operates, and we're able to do that through the telematics data. And so we can then also fold in some additional variability and model those scenarios so that we understand, yep, that's a vehicle that would make sense or wouldn't make sense to transition to an EV. Next slide, please. So this is kind of a little bit of a peek behind the scenes. This is what we're looking at. So what the software is doing when we're ingesting real time all of this operational data from vehicles. And this is a snapshot of, this is actually from a diesel truck that we observed. And this is one vehicle, this is one trip, and on one day. And so we map that top section there, and we calculate how many megajoules of energy, just raw energy, were required throughout that entire trip. Then we can take that and we can map that onto what we would call like an EV candidate, which really is just any vehicle that's available currently in the market. We can build all of this intricate specs for each one of those vehicles so that we know exactly how much energy is required for that vehicle. And so really for any fuel type, we can do this and really understand very precisely, what kind of energy is required. Does it make sense? Or would the driver be required to stop mid-shift? And so all of these different factors is kind of where we start. So we have to map all of these trips. Sometimes we'll work for years with fleets, and we see a lot of these different parameters, different things changing. And so the more data that we have coming in, certainly the better that it is, because then we're able to capture all that variability. And next slide, please. So this is actually a screenshot on the right there from our Easy EV tool, which again is kind of usually where we start when we're working with on a project with a fleet. What I want to highlight with this particular screenshot is that we've built out into the software all of the specific inputs and the different variabilities that fleet has. And so these are variables, these are inputs like fuel price, so your specific fuel price, your specific energy price, your vehicle prices, all of these different things. We're building that into the software, and then it's ingesting all of this telematics data, analyzing all of that, and then if you look at that recommended replacement, the software has actually identified that the 2026 Kia EV9 long range vehicle would be the best replacement for, as you can see there, the model is actually, this is an existing 2018 Ford Explorer. So if you were to replace that 2018 Ford Explorer with the Kia EV9, that would probably work out. We've got a lot going on there with our scoring methodology. That might be another conversation. All of these different parameters, though, fit up, kind of form what our overall score is. And why I wanted to highlight this one is because, again, with the idea of that digital twin, using the drop down right there on that select vehicle to compare, we can build in as many options as an organization is interested in comparing. And so that gives us the ability to, once we've modeled all of that behavior for, in this case, for a year, all that driving behavior, we're able to go in and look at these different scenarios. Maybe the Kia's not available when you're needing to make your procurement decision, but hey, the Blazer is. So that looks like that'll work. And then one other aspect there is that midday charging needs. So that is critical. And the idea why we want to put that verbiage, on this individual vehicle page is really to help stimulate a conversation also just as much with us working with the fleet as it is internally with the fleet. And so then this helps us to understand what it looks like is that, if we were to replace that existing Ford Explorer with that Chevy Blazer EV, potentially or most likely twice a month, we would then need to have the driver stop and charge. And then the conversation can be, is that reasonable? Can we work with that? Is it too disruptive to our daily operations? And so by understanding that and how that would actually play out day to day, what that would look like or what that could look like, we can really fine tune what's going to be the perfect model to replace that existing vehicle with when it's ready to come out of service. Next slide, please. This is actually also from Easy EV. So just another tab basically within the software. But on top of identifying, is it a good fit? Is it not a good fit? What EV model would be a good fit to replace that existing Explorer with? We're also then looking at where is that vehicle parking? We're looking at the location. We're also looking at the length of time in which that vehicle is parked at a specific location, and then the frequency in which that vehicle is parking at that specific location. So as everybody knows, there can be a lot of variability. Sometimes we see a vehicle and it's got, 25 different locations that we observed it parking for these sort of more extended dwell periods. But we want to highlight that because it wouldn't make sense to go in and put charging stations at all of these different places where this vehicle has been observed to be parking overnight. Where is our best place? And so in this case, we can see 95% of the time that vehicle is parking at the REI flagship store in Denver. And that's the length of time that it's parking there, which if you look to the right there, that charge time and cost, that tells you on average, how long would it take to replenish the battery from the previous day's use? So that helps answer the question, all right, if we put a charging station at that REI to support this vehicle charging, will it have enough time to recharge from its daily use? And so we've got a lot of information there. There's a lot to it. We've got level 1, 2, DC fast, what that would look like, fuel costs. But the really big thing that I like to point out on this slide in particular is in the bottom right-hand corner, there's that daily energy use graph. I love that because what we're showing there is, and we're able to do this, of course, with the telematics, is month over month, what the average energy on a daily basis would be required for this specific vehicle. And that's the dark blue part of that bar graph. The light blue part highlights the max energy consumption that we observe during that month. And so in the software, actually, if you can hover over those things and it'll tell you exactly to the day when that happened. And then there's a dotted line there. That's an orange dotted line that represents the total battery capacity of the vehicle that we selected, which, if you remember, in this case was the Blazer. So we can see where that approximately twice a month the driver would need to stop and plug in during its shift, because we can see some some of those light blue lines are exceeding the total battery capacity. So that gives us so much insight into how that vehicle is operating and what it would, again, potentially look like as a Chevy Blazer. Next slide, please. So shifting now into EasyIO. So this is this is how we analyze our infrastructure and how we can fine tune recommendations and identify what kind of infrastructure would be required. In EasyIO, we have the ability to look at the entire fleet or just one vehicle. We can look at 1 month. So because we have that data, we're able to really drill down and get very specific with how vehicles operate. And we can see on the left there, that graph there, the bar graph, monthly kilowatt demand peaks. So what we're highlighting there is there's a lot of variability. So we can see in September, October, November, December, this is all from one individual location. All of those vehicles that are coming back and would require to be plugged in. So this is mapping their existing internal combustion engine vehicles and what those patterns look like as those vehicles come back to this primary parking location day after day. And that's actually pretty common. Sometimes we'll work with a fleet that has maybe half the year they use their trucks for plowing snow, and then maybe the other half of the year those trucks are used for landscaping. Two very different applications, and especially in terms of energy consumption, drastically different. And so because we have the telematics, we're not just looking at a total average AVMT for a specific vehicle that's parking at a specific location. We're able to really see this is exactly how these vehicles are operating. And we can fold all of that in to really understand what our recommendations are, what's going to make the most sense from a strategy standpoint of those vehicles, to electrify. Shifting over to the right, actually, there's a line graph there. Same location, that is showing 1 month, actually, of that bar graph to the left there. We've got a lot of gray lines that are on there. Each one of those gray lines, and in the software, same thing, you can hover over it so you can see exactly what day that was. That's showing the operational patterns of those vehicles as they're coming back to this specific location and what that peak looks like. So this is pretty typical, where we've got that big peak in the afternoon as drivers are coming back and parking those vehicles. And the neat thing about seeing this is that also then opens up a lot of opportunities to look at different scenarios to reduce that peak. So we can see that it really spikes up a lot right there, where we're having this concurrent charging events as these vehicles are coming back and plugging in. But they're only really, that peak is really pretty narrow. It's only hitting that high peak for, like an hour and a half, maybe 2 hours. And then it's dropping off. It's dropping off because then the vehicles are charged. And so by having this kind of information, then we can start thinking about staggering those charging events, managing the charging scenarios, or the strategy. Basically, this informs the charging strategy for this specific location with those vehicles that are always going to be parking there. And then in the middle there, that last one is the primary parking locations that we observed. So if the graphs on the left and the right are showing that individual location, if we can also scroll out and look at the map view, and we can see this is where all of these vehicles are parking. So these are all observed dwell locations for the vehicles that we are observing in the study and analyzing. And maybe it would make sense, maybe not all of those are owned by the fleet. Maybe we need to consolidate that. Again, because we have that telematics data already, we can model all of these different scenarios until we find what's going to make the most sense, operationally and from a cost saving standpoint and otherwise. Next slide, please. I love this one. So actually, my colleague Martine put this together. We were working with a pretty large fleet that was very spread out geographically. There was a lot to get your arms around, but because again we had that telematics data, we're then able to really take this and really crunch these numbers. So so the kind of, I guess you maybe call it a baseline. That first bar there, we're looking at over $1 million just for charging infrastructure for this particular fleet if you were to do a 1-to-1 ratio. And so there's a lot of rule of thumb that has been out there for a long time. For a long time it was we just got to do a 2-to-1 ratio, and that'll be that. You can do that, and that has its place. But when we're looking at a very large project here of implementing charging stations all over the place to support this very large fleet, we can really, by fine tuning it, we can really reduce that cost significantly. So the second one there, that 792, that would be what the charging stations would cost if we were to reduce the number based on just the active days that those vehicles are driving. So we're going to look at a location and we're going to see, all right, maybe this one vehicle is only driving 2 days a week, and so we can kind of back into it that way, reduce the port count a little bit to save on some costs. So we've got a 22% reduction in that strategy. The next one, 35% reduction. What if we take what we know about how our fleet is operating and move away from the 1-to-1 or 1-to-2 ratio rules of thumb, and we can look at just the daily battery consumption of those vehicles. So you can already get that. If you just start tracking, maybe you've already got a bunch of EVs, you can maybe track what that looks like. Well, now we got 35% reduction from that 1-to-1 ratio, but we're leaving a lot of money on the table with using the telematics data and really analyzing it and fine tuning what's actually operationally an exact fit for the fleet. We've got a 65% cost reduction from that 1-to-1 ratio where we were just kind of guessing a bit. And so that to me is very powerful. And that underscores sort of the level of granularity that we can get into, and translates to serious cost savings, on the charging side of it. So this is these are actual numbers from an actual fleet that we worked with. So that's pretty powerful. Next slide, please. Moving into, now we've already got, if we're thinking about what this scenario is, if you're the fleet manager, you got a bunch of EVs that you've got deployed in the fleet, and also PHEVs there. In fact, I selected that image specifically because we've got a PHEV there, vehicle 9, if you look at that driving activity. So this is when we're talking about really optimizing the way that the vehicles are being driven and how we're managing those alternative fuel vehicles. So that's a 2022 Ford Escape. That's a plug-in hybrid. We can see during the period of observation, we observed 17,430 miles. We'll tell you how many kilowatt hours of electricity were consumed during that time. Miles per kilowatt hour on that particular one is grayed out because it's a PHEV. Hours of operation, and on the right there, electric mile percentage, 6. So of the 17,000 miles this vehicle drove that we were ingesting telematics data on, only 6 of those miles were electric. So it's not really a surprise that that vehicle is not saving this fleet any money because it's not being plugged in. And with being able to have all of that data at your fingertips, that gives the fleet manager an opportunity to say, hey, you should plug that PHEV in because you're just driving around like a normal car and just carrying around all this extra drivetrain equipment unnecessarily. That's costing us money. And so we're not able to achieve that cost savings that we were shooting for when we decided to put a PHEV in that application. Um, Similar things on like on the Lightning and the Bolt. So um, both for PHEVs and then also for EVs, because we're using that telematics data, we can look at all of the charging events and all of the activity for those vehicles where they're dwelling, for example. And we also already know where all the charging stations are in the map. And so we can identify very easily if, for example, vehicle 9 was parked in close proximity to an existing charging station. And then if we see that it didn't plug in, there was no charging event, well, that's a missed opportunity. We got to keep as many, with EVs, the more you drive, the more you save. And so we really want to try and maximize those electric miles so that, we're achieving our cost savings projections. There's a lot in Ion EV. I could spend a lot more time on it, but we'll pop to the next slide, if you will. Thanks, Ulrich. And this next one here, so this is from our emit dashboard, which again is really designed to help fleets track the emissions reductions over time and understand what the impacts of adding these different alternatively fueled vehicles into their fleet result in. And so we're looking at some of that variability. So this is a snapshot, 1 month in time. And we can break this down based on drivetrain, vehicle types. We can look at vehicles only in a certain department or in a certain location, and we can really fine tune just exactly what it is that is being required for reporting. So again, this is very popular with some of our over-the-road customers where they have to be able to report on what their emissions are, and so this just makes it super easy to go in there and everything is compliant, SOC 2 compliant. So there's a lot there, and this is very precise because, again, we're using that telematics data to drill down into all of those granular specifics. But that's really all I've got today, and I'll pass it over to Katie next. And thanks again for the opportunity. And there's my contact info there. So feel free to reach out if there's any questions. And thanks again. I'll hand it over to Katie.
Thanks, Jared.
Yeah, thank you, Jared. And next up, we have Katie Fletcher. And so Katie Fletcher serves as the Sustainability Program Analyst at Denver Water, where she's part of a great team that has done a number of different things in terms of looking at various sustainability initiatives within the organization that includes fleet electrification, waste diversion, carbon reduction, as well as employee outreach and education. And most recently, Denver Water was recognized for their great efforts as being one of the 100 best public fleets by NAFTA in 2026. In her spare time, Katie enjoys the outside, like in terms of hiking, bird watching, and photography. And she has a BS in environmental, earth science, and sustainability from the University of Northern Colorado. Katie, I'll let you take it from here.
Great, thanks, Ulrich. Very excited to talk to all of you guys and share a little bit more about the fleet electrification journey that we've had at Denver Water. Go ahead and hit the next slide. Awesome. So I did want to share just a little bit of a background. Oh, if we go back to one more, sorry. All right. I did want to share a little bit of background about Denver Water since I know many of you are from different areas and this is from all over. So Denver Water, we're the oldest and largest water utility in the state of Colorado. We serve about 1.5 million people in the Front Range of Colorado. And if you're unfamiliar, that just means we are in front of the mountains. And that's about 25% of the state's population. And we do that using less than 2% of the state's water. To talk a little bit about our operations, we do operate out of 12 counties in Colorado. We have a total watershed area of 4,000 square miles, and we have 3,000 miles of pipe in our system. All of that put together, given our size, the different functions that we have, this creates a lot of operational complexity, especially for our fleet. We do have about approximately 1,100 employees all over the state. The majority of them do operate out of our main operations complex, which is in the heart of Denver. But we do have folks that report out of different facilities throughout the region, including up in the mountains. So, given that we are a water utility, we have a large service area, we have a huge variety of job functions. We have a huge variety in our weather conditions, and all of our vehicles have a lot of different requirements for the jobs that they do. So all of this put together made fleet electrification a bit of a challenge, and it was something that we did not have any experience in a few years ago. So we did actually do a fleet analysis with Swatch Labs, and I'll talk a little bit more about that as we kind of go through this, but we can go to the next slide. So I did want to highlight some of the sustainability goals and commitments that we have as a water utility, as Denver Water, as they relate to fleet and some of our other carbon reduction goals. So as a sustainability team, we do put out the sustainability guide that has a variety of different chapters that we work on the teams with in our organization to come up with these specific goals, commitments, or standards. So these are just a few that I have pulled out that relate to fleet. The first one, though, is one of our more overarching goals, and this is capturing a lot of the different work that we do. But our goal is to achieve net zero carbon emissions by the end of 2030. This was a board resolution from our Board of Water Commissioners, and they put that forward in November 2024. So this is a big, aggressive goal. I'm sure a lot of you have different goals at your organizations. We looked at what different water utilities were doing, what different counties were doing, and 2030 is a pretty aggressive goal, but we believe that we can get there. And one of the aspects of that is fleet electrification. So kind of rolling up into that, one of our specific goals is to replace all of our SUVs and light duty vehicles with electric or alternative fuel vehicles by 2029. But we recognize that based on the market, based on the types of vehicles that we have in our fleet, that for some of our bigger things, we are going to just have to consider some alternative fuel vehicles as they become available, as technology improves. So in terms of the net zero carbon goal, we do not expect to have 100% of our fleet with every single piece of equipment electrified by 2030. We know that we'll probably have to do some offsets for that, but we are striving to get as close to actual net zero as possible without the help of offsets. So we can go to the next slide. So to get a little bit more into the nitty-gritty of our fleet, we have over 800 total assets in our fleet, and that includes our yellow iron, so backhoes, road graders, things like that. We have other heavy-duty equipment and trucks, so we do have lowboy that haul trailers, we have water trucks, we have dump trucks, all of that. We have generators that our fleet team manages, and we also have different trailers, and then we have all of the vehicles, the people movers that we have. When we did our initial study with Swatch Labs, we included 490 of those vehicles in that analysis, and that really focused more on those people movers, those vehicles, the things that we knew there were at least some options for in the market. So we did not include any of our construction equipment, yellow iron, things like that. At the time of the study, most of the vehicles in our fleet, and I should even say really now, most of the vehicles in our fleet are 3/4 ton trucks. Several years ago, before even I was at Denver Water, we had standardized to a 3/4 ton truck across a lot of job functions, but now we're rethinking that. So we are getting away from some of the 3/4 tons, but that is the bulk of what we have currently. Our fleet team, which Ari, thank you for the shout out. Yes, they have been honored as one of the top 100 fleets from NAFA. And then last year, they also were awarded the Green Fleet Rookie of the Year, which we're very proud of. But our team oversees the maintenance of the vehicles at our on-site fleet building here at the operations complex. But they also are in charge of our procurement and the strategic planning of purchasing electric vehicles. Our telematics are provided by Geotab. They previously were provided by Network Fleet, which was a Verizon product. And actually, our fleet study with Swatch overlapped our switch from Network Fleet to Geotab from AT&T. So that was actually a great learning experience for everybody that we got to kind of experience uploading data from two different sides of software. Next slide. So we do have some specific fleet challenges, and these are things that Jared sort of hit on in his presentation, so I won't spend too much time on this, but being in Colorado, elevation and weather conditions are one of the biggest factors we have that can impact the range. So driving, for example, yesterday, I actually took one of our fully electric Silverados from Denver up into the mountains and had to drive, a lot of hills, and it also was cold and rainy. So immediately, the range was a little bit less. That's something we've had to get drivers used to. We do have spread out operations, and a lot of these spread out operations are in rural areas that are pretty far away from other infrastructure, other grid connections. So we have to think about that when we assign vehicles based on their job function. Is this a truck that's going from Denver up into the mountains a lot? Are they going to have access to a charger along the way if they needed it? Is there a charger at the end location? That's the type of thing that is one of our challenges. And we do have some specific upfitting requirements for a lot of our vehicles based on their specific job function. So we have crane trucks, water trucks, meter reading vehicles, things like that. So we do just have to take that into consideration when we look at the replacement options that we have. And our study with Swatch was great at including that. We did make a note in some of the vehicles. For example, this vehicle does have to put a plow on the front of it. This vehicle has large toolboxes, so we did include that in the analysis. Another challenge that we have is 24/7 operations. So we do have to be able to respond at any hour of the day or night for a main break or any other type of emergency that we might have. So we have to be able to have vehicles that are ready to go out immediately. We do actually now have some of our 24/7 operations folks using EVs, and they have been doing very well. But that's thanks to a lot of planning we've gone into and infrastructure that we've put in specifically for that. I already mentioned lack of existing infrastructure, but it's worth noting that that's both on our side internally, and we're working on that, but also the state of Colorado. So the state is working on improving EV infrastructure along major corridors like I-70 or I-25. But we are kind of at the whims of the state when it comes to that or other public businesses. But in the mountains, it's not something that we have a ton of currently. And then, of course, the vehicle size versus availability in the market. Since I mentioned that the vast majority of our fleet is 3/4 ton, we found, there are great options in the half ton and there's options in the larger vehicles as well, but there's not really a direct 3/4 ton option, at least when we did our study. So we started to have conversations internally of, does this truck actually need to be 3/4 ton? Could it go down to a half ton? And now we've actually started having conversations with other teams. For example, our electrical shop, they are actually going from trucks to vans, which is more industry standard for electricians, and they are going to be the EV Ford Transit vans. So helping us just be a little bit more flexible on not just being type to type, size to size. But we do have to obviously wait for some things to come out in the market for things that do need to be 3/4 or 1 ton trucks. Next slide, please. So there were a lot of benefits of doing our telematics study, kind of like Jared alluded to. But one of the things that I really want to highlight is being able to create buy-in from executives. especially if you have a group of executives like we do who are very focused on metrics, and that's something that really drives decision making. This was really beneficial in demonstrating the return on investment, demonstrating the improvements for total cost of ownership, and also our greenhouse gas savings, which is really important for that overall goal that we have from our board. So, all of that together, being able to show that was huge for us as an organization. This was also really important with our data-driven decisions for specific vehicle choices. And that was really important to help kind of ease the driver anxiety. So like what Jared was showing, I actually have a screenshot as well from one of our suitability assessments, just showing that, hey, your vehicle actually is a really good fit for an EV. We don't anticipate that you would need to charge in the middle of the day, and that is based on what your vehicle does specifically. So we were also able to tell people, hey, your vehicle actually was not a recommended vehicle. So we're not going to focus on that right now until we can change some of those uh, factors and variables to make it a better fit. So that has helped us ease a lot of driver anxiety when making the switches. This study also has helped strengthen our grant funding proposals. So we have done several rounds of grant funding from the state of Colorado for both vehicles and for infrastructure. So being able to demonstrate in these applications that we have done some pre-planning, we have actually looked at the specific data of our fleet has been huge in helping us secure funding and helping us make these projects happen faster. And similarly, internally, these have helped us with our infrastructure planning and our capital planning. So it is important for us to be able to align when we want to install an EV charger, especially at some of our very critical infrastructure locations, that we can't turn off a treatment plant for an outage to install a level 3 charger just willy-nilly. We have to plan that based on scheduled plant outages so that we're not causing operational disruptions. So having this information is really helpful in that longer range planning. And you can go to the next slide. So we were able to really implement a lot of these findings from our study, and now that we do have a new fleet manager who has a lot of experience in electric vehicles, but before he got here, this study was really, really beneficial for us in getting started and getting this program off the ground. So currently, we have 40 EVs in our fleet, and by the end of the year, we anticipate that we will be at a 60 or higher, just depending on when things are delivered. We also purchased the first Class 6 EV truck in the state of Colorado last year, and we've been using that on a project here near our operations complex, and it's been going very well. We've also used the infrastructure portion of the study to help in installing some charging. So we have installed a level 3 fast charger at our main complex throughout our system. Again, using those maps that Jared showed, we picked out different locations in our service area and at our specific properties to install 26 level 2 charging ports. And we also last year purchased an off-grid solar EV arc beam charger that we're going to be able to transport to some of our locations that really are lacking in grid infrastructure for bigger charging. This also helped us, again, create a roadmap for planned installations. So looking forward into the next several years of capital planning, we were able to look at locations on the map and just kind of pinpoint what we might want to do next and align that with vehicle purchases. You can go to the next slide. So just to wrap up some lessons learned, our successes, again, getting buy-in from executives and funding, both from state grant purchases, but also getting dedicated funding in our internal budget. The telematics was crucial for that. We were able to specifically pull out the list showing, hey, if we were just replace even the top 10 vehicles that are recommended, that would save Denver Water X amount of money, X amount of carbon emissions. So that helped us get specific funding for those vehicles. Again, we used this study just to launch our initial EV program, and it was so helpful for us to lean on outside expertise since we were still new to this type of work and new to this type of programming. Our study was 100% reimbursed through our utility provider, Xcel Energy. They have a program, the Fleet Electrification Advisory Program. It might have been renamed since we've done it, but I would highly recommend looking into that option. So if you are able to find funding for this study, that is a huge, huge benefit. And again, for those of you who have carbon goals or sustainability goals, using the greenhouse gas reporting from Telematics is a great way to leverage change and to leverage action from your organization. But of course, it has not been, 100% smooth sailing. We have had some challenges. Again, kind of aligning our capital planning, our capital vehicle purchases, and grant funding and replacement cycles for vehicles. We're still working through some of those challenges on the best way to move forward. But we're still ironing out the kinks, and we're still accelerating this program faster than I thought we would be able to, which has been fantastic. And then, of course, this is nothing nobody's ever heard before, but competing capital projects and budget cuts. We are in the midst of a historic drought and a historic period of capital investment at Denver Water. So all of those put together does make that challenging for fleet vehicle purchases and other things like that. But we are able to still get a lot done thanks to the information that we have from our telematics. So that is what I have for you. On the next slide is my contact information. It does ask about questions, but I believe we are saving those until the end. So thank you.
Thank you, Katie. It's very informative. So our last and final speaker, whose name needs no introduction, is he is very synonymous within the fleet world for having a stellar reputation in terms of his leadership and his role. Ronald Worth has his career spans over 3 decades within the leadership that focuses on collaboration, planning, and sustainable operations. Uh, Going back to 2012, which is since Ron has been with the County of Sacramento Fleet Services Division, he currently looks at basically advancing fleet sustainability initiatives and still manages the specifications and the procurement process. Past 3 years alone, County of Sacramento, underneath Ron's stewardship, has been ranked #1 Green Fleets by the Green Fleet Awards, #2 in NAFA's 100 Best Fleets, leading the space in #3 by Government Fleet, and has been named the leading public fleet by Expo. And I'll throw one more accolade in there. Ron was also a 2026 finalist of the Tom Johnson Awards. Uh, so, Ron, I'll let you take it here. The floor is yours.
Thank you, Ulrich. How much time do I got? 15? I just want to make sure that we're
Uh, yeah, say 15 minutes is good.
okay. Just skip to the fourth slide. You'll see a map. Uh, Good morning or good afternoon, everyone. When we get to this slide, we're County Sacramento. Large part of this presentation is going to be looking at your fleet, your unique use cases, and how to assess your fleet, and then looking at trip data, telematics data, and some strategies around vehicle replacements. So for those of you who don't know, if you look at that map, Sacramento is a very large county, 994 square miles, large population. We serve a lot of departments that are listed there. But you see that lower leg of that map, that's all Delta, it's all rural, and it presents some challenges for electrification and even other alternative fuels. Next slide, please. Some visuals here just to show some of our older infrastructure. We actually maintain even bridges in the Delta. Next slide. And I'm going to be moving through these pretty quickly till we get to the important stuff we want to spend time on. So our fleet statistics were about 2,800 fleet. You see our makeup there. About 460 of those are department-owned vehicles, and we'll talk a little bit about that. 21 million miles, that's about average, or 21, 22 million miles a year. And you see we burn a lot of fuel. Next slide, please. And I want to say a lot of what we're looking at would not be possible with a large dedicated staff here at County of Sacramento. I'm decent with Excel, but most of what you're going to see, I have to rely on people a lot more knowledgeable than me to make this all palatable. So why electrify your fleet? And that sounds like a simple question, but for your purpose, you really need to dig into really what are the reasons. Is it an organizational goal or executive directive if you're a private fleet? Climate action plan, regulations, greenhouse gas reduction, fossil fuel consumption, because all of these, you could be in an organization where all of these apply, and some of them may be in conflict with each other. And so you, as a fleet manager, you're going to be doing a lot of communication, a lot of strategizing about how to meet all these goals or which ones are going to take priority. And so and even marketing, if you're in a private fleet and you want to market to your customers that you're, running environmental equipment, that's even a factor. Next slide, please. The next slides, we're just going to go right through them. So we have county initiatives. We have regulatory compliance, both on a state level and on a county board of supervisor level. And again, a lot of those have very distinct goals and not a lot of them are aligned. So you have to navigate that. Next slide, please. And with the time constraints, I'm not able to dig into a lot of this stuff as much as I'd like. These are some visuals, but the point is, know your fleet. Looking at data and being on site at your location is one thing, but get out and really visit some of these sites and see how these crews are using this equipment. Some of it may surprise you, some of them may not surprise you, but you've got to understand the auxiliary loads that are happening, especially for a fleet like ours, where most of it's municipal maintenance. Getting the truck there doesn't get the job done. It's the work that happens on the job that is the point. Next slide, please. And this just shows some of those scenarios that I'm talking about with the bridge maintenance and paving and like that. Next slide, please. Next slide just shows some of the diversity of our fleet and some of the various equipment that we need to maintain and plan for replacement. And just go ahead and go to the next slide, please. So as far as a strategy, here at the county, we could look at passenger cars, pickups as like a non-regulated part of the fleet. And then look at the heavier for us in California. We have CARB ACF, which means as a public fleet, every vehicle we purchase over 8,500 GVW has to be zero emission or EV. And so how do we achieve that? Well, we've got to look at the light fleet. It's not the first choice, but in a lot of cases, we've had to look at pickups, and where normally you'd want to downsize, with a lot of our equipment that we cannot replace as EV yet, and we'll look at some examples here in a couple slides. We're actually having to upsize some of our pickups to get them into the 8,500 range in order to have offsets so that we can purchase other heavier vehicles that we need to um, still buy, and we can't equip them as EV. And so considerations for all this, you see that list there. Telematics is a must. If your fleet doesn't have telematics, you've got to figure out a way to get that implemented in your fleet, and we'll look at some ways to do that. Utilization, focus on utilization because at replacement time, that's an optimal time to either downsize or right size. Look at those department-owned vehicles, or most of the time they are aging and they need to be replaced, or maybe the departments don't need them. Life cycle forecasting is a huge part of this, and we'll look at that. Outside consulting, you may not have the time or the staff to really dig into this, and so consider a third-party consultant. And I can't touch on all these, but we'll touch on the important ones. Next slide, please. This next slide shows an offset sheet that we maintain. And so for every vehicle we have to buy over 8,500 pounds that we know we can't electrify, these are heavy service trucks with cranes, ton of auxiliary loads, or animal control that have AC systems that batteries just won't operate all day. In Sacramento, we regularly have days over 100, up to 108, 110 degrees. And so the animal control AC systems have to run all day. And so what we do is, you see on the left columns there, those are all of the e-transits, for instance, that we purchased so that we can buy other heavier vehicles that you see listed on the right. And basically, this is how we keep track of our 50% or 1-for-1. At the bottom of the sheet, you see some that don't have matches, and those are vehicles that we just are not buying until we have an EV that we buy along with it. But the sheet displays something else also. We are buying EVs in our fleet in places where that we can put them, but then when we reach out to a department that needs heavier vehicles, we can show them this and say, look, we've already allocated other vehicles in the fleet that we purchased so that we can purchase other vehicles that you need. And we've not had to impact you with these purchases, but sooner or later we run out of those. And this is a discussion point where we show them this and say, look, this is what we've been able to contribute, but now we need we need some skin in the game. And this is how we kind of start these discussions or, navigate through them. Next slide, please. I can see we're going to be really short on time. The next two slides, I'll have Ulrich go through them just in succession. But they show a vehicle that we were replacing, like that complex sign truck, and the alternative EV that we were able to replace it with. So this shows a Ford Lightning. That Lightning cannot do all of the work that truck in the upper left shows. If you can back up one slide, Ulrich. Back up to where it shows a E-Transit cutaway. That sign truck, there were 9 of those that we're replacing. We talked to the customer, looked at those offsets, and we talked to them, hey, can we replace 3 of them with this Lightning? And so they were able to do that without impacting their operations. The other part of the story is they have 5 other trucks that weren't being replaced. So this is 3 out of 15 that they're able to make work. Next slide. The next one is a E-Transit cutaway that is an alternative to a service truck. It's longer. They actually gained some storage space here. But for the trip data, this was able to work, and we'll look at some of the ways we look at trip data. Next slide, please. The point of the next slide is basically, it's very important to keep your fleet management, the basics of fleet management intact. Don't get hyper focused on meeting these goals while you let other parts of your fleet, fall behind. Because, maintaining safety, PM currency, PM quality, utilization, all that stuff goes hand in hand with all these goals you're trying to achieve. So don't let that go. Asset management, don't you've got to be a little bit of a salesman when you're talking about funding to replace vehicles. It's expensive to replace vehicles. It's more expensive to run old vehicles that are way past due replacement. And so you've got to be able to make that case. And with the data is how you make that case. But don't run inefficient vehicles, even if you can't find the perfect fit. You're better off buying a new modern vehicle or a hybrid or a plug-in hybrid before, rather than running an old piece of equipment. Next slide, please. We're getting short on time, so we're going to skip forward quickly here. The next slide just shows, as a fleet manager, you're going to be central in the whole line of communication. And I got to give David Worthington from County of Santa Clara credit for this slide. And I believe David Rensler also from City of Fairfield. But whether you want to be or not, you are going to be central in that communication. And these are all of the departments and entities that you're going to have to be in communication with to make all of this flow. You see real estate there, and why real estate? Well, in the county, we have leased facilities, and we need their help in order to negotiate terms in order to put charging infrastructure on leased facilities. Next slide, please. All right, previous presenters here have talked about the telematics benefits. For us, I want just emphasize safety, obviously, but also asset management. I know it's way down at the bottom, but it's something we rely on a lot at the county. And Ulrich, if you can slip right through 2 more slides you'll see a chart of a table. What he's skipping through are just some parking location maps. Yeah, and I'm sorry, back up 1 slide, Ulrich. I'm sorry, I'm trying to follow along on my own copy and I got ahead of myself. Implementing telematics. If you are a public fleet versus a private fleet, there are different challenges there. And even if you're a private union fleet versus non-union. So what I would urge you to do is look at all your policies, transportation policy, utilization policies, bargaining units, even job descriptions. Make sure all those policies are up to date in order to, because you may be surprised at some of the content in your policies that make implementation of new technologies a challenge. So you want to address those as soon as you can. Next slide, if you go to slide 22, which is a table. We're about out of time, and I want to touch on how we look at fleet trip data. Yeah, right there. Okay, so those 9 trucks we talked about, this is their trip data for a whole year. And we put this report together. It's very simple. This is a Excel export of telematics data, and based on a lot of vehicles in the market and range anxiety of our customer, I figured that 110 miles is a pretty safe range to expect out of just about any EV out there. that's available today. And so we looked at those sign trucks. This is when we had the discussion of giving them 3 lightnings. And this was the trip data. And we look at how many days in a year did each vehicle go over 110 miles, what was their max, and what was their average daily distance. And if you see that average daily distance, and if you think about a Ford Lightning that has 320 miles, this is a perfectly doable just for about every vehicle on that sheet. Those red arrows mean, if you look at that 4 times it went over 110 miles or 19 times, we determined that 19 times is a vehicle that goes home every night. It's a home retention to respond to, events. So we kind of kicked that out. But if you go to the next slide, and I'm past my time, so I'm going to go very quickly. This is where we drill down and find out that those 4 times, once you get beyond that, you're really looking at a 95-mile range. And when you really dig in, you can find out that maybe there are some opportunities that you don't have to generate those miles. Next slide, please. And we're going to get really short on time. Next slide. This is where we look at annual miles traveled by class. And so we use that data to figure out some of this next stuff. Go ahead and next slide. We also look at our annual fuel consumption. Every year I total up our fuel consumption. And within that, I also look at our electric vehicles, and we use this data to then project, do charger projections for different parking locations. Next slide, please. The next slide shows our totals, and basically this is where I keep track of what percentage of our fuels are alternative. We even hold out hybrids. There's one calculation for hybrids, including hybrids, and one that doesn't include hybrids. And you can see our alternative fuel burn is right around 61% as of last year. Next slide, please. Replacement forecasting. I'm not going to talk much about this, but we're going to just flip through the slides. And if you go ahead and go to the next slide, all right. But our average fleet age for our rental units is 5.1 years. And we built a replacement forecast that forecasts and shows what we have budgeted, what's coming up for replacement, all for every vehicle in the fleet, clear out through the whole life cycle. And you can see that. This adds an inflation factor. And we can look at the average age of each class of vehicle in the fleet. This is the dashboard. There's a lot of data behind it, and we can sort to our heart's content. Next slide, please. This just shows all the things we can sort behind the scenes to look at that dashboard the way we want to look at it. Next slide. We put together a version of this to account for EV transition as well. So here you see department owned, and you look at the average age of the department owned. This is time to have a discussion. It's like we need to get these vehicles out of the fleet, even if you aren't responsible to maintain them or they're not part of your rental fleet. These will plug up your shop and even create staffing issues for you if these older vehicles are allowed to remain. So look closely at that. Next slide, please. And I'm over, but I'm going to finish in a minute. Next slide. This is the EV transition where we add, this is the light, and we also have one for heavy. This is kind of what I wanted to get to. All this data we take and we can sort by department and give them a charging projection and look at when new vehicles are going to come into the fleet that are going to be electrified out each year. And then we can take their vehicle, their VMT for the previous year and figure out the charger ratio and then put out a charging projection. You see the 10 and the highlighted on the right. That's kind of like if you're going to start digging trenches, you might as well just put in 10. And I have a giant disclaimer on the right that's tiny, and this, the way it looks, is I'm not an electrical engineer. This is just a simple math problem as to how many ports per vehicle and how much electric is needed. That's not accounting for any charge management or avoiding peak charging times or any of that. Next slide. And then I'm going to cut it off after this one. This is a more complex charging projection that includes everything from class 1 all the way out to class 8. It includes another column where it shows our total replacements, and then the one in the peach column is how many of those are going to be electric. And by the way, all these peach columns are tied to formulas. We can change those. We can change up at the top. You see two where they can change their work days per year, which affects your kilowatt hours per day usage. You can also put in a factor of 30% peak because not all months are the same, not all days are the same. So you can look at your average and then add, what do we want to add for our peak? 40% or 30%? And we send this to the customer and they can play with their numbers, and they can also, if they think they're going to grow over the next few years, like 20% by 2030, they can put those growth factors in. This is just a starting point and a conversation starter so they know what to look for charging infrastructure at their parking locations. I think, well, I'm over time, so I want to be respectful. So I'm going to cut it there. If Ulrich, if you want to just go to my contact information, and then anyone that has questions, they can reach me that way. While you're doing that, we've done a lot of analysis on heavy trucks, what they require for charging. There's some graphics in here I got to give David Worthington again credit for. Thank you for your time. Sorry I went over, and there's my contact information.
Okay, I want to thank all the presenters once again. Think we have a few minutes here, and then we want to go ahead and open up to Q&A from the audience. Are there any questions from the audience? And so I don't see any. So I have a couple of questions for Katie and Jared. Feel free to chime in since you all did help out with this sustainability study, as Katie mentioned earlier. What were some of the first vehicles that you prioritized switching after the telematics study?
Great question. So we focused on a few specifically, we did some Ford Lightnings. Those were some of the first ones that we brought in, and those were brought into like our recreation group and some of our engineering teams that do inspections and things like that, as well as SUVs. So we have done now a lot of SUV switches, and pretty much every vehicle in our motor pool that you would be able to take out, like if I wanted to check out a vehicle, they're all electric now.
Okay. Jared, would you like to add anything?
Really, I remember very distinctly, really spending a lot of time on the Denver water study, zeroing in on a lot of market conditions as well. And so it was kind of funny, actually. I love to see that slide that Katie had earlier where I put in resale on there.
Oh, yeah.
So one of the things that we did was we looked at current resale values for their existing vehicles. And then we actually folded that in as well. So I created two where we had like, all right, this is just the base price of the new model. Here's what if we look at, all right, if we sell this at auction, less any fees and things like that. We folded that into, and yeah, it was a great study. And yeah, it seems like things are continuing to move pretty quickly over there at Denver Water. So it's great to see.
And so I did see a question pop in from someone from the audience. So are they curious to hear about the ballpark cost range for an electrification study? So this is open to each of the panelists. You all want to weigh in?
I can
Um, oh,
start.
go ahead,
Go,
Ron.
no, go ahead, Katie.
I was just going to say that and again, keep in mind this was a couple years ago, but we were reimbursed $40,000 for a 12-month study from Xcel Energy. So and I don't know if that was programmatic pricing or anything like that, but that's a good ballpark, at least on our side of things.
Yeah, and I will say, boy, it is so fleet specific and based on geography, and makeup of your fleet. Um, we went out to bid for and we contracted with a third party consultant, and it was a pretty major undertaking, because we can look at fleet and look at fleet vehicle replacement costs, but I'm not a contractor, I'm not an electrical engineer, and so it gets tough to estimate those types of infrastructure costs. So we have brought on a third party consultant to look at that and look at our parking locations, and we're embarking on uh, an effort to estimate our overall costs over time here at the county now. So that's a tough one to answer. So I'm sorry to be kind of vague.
I would
So
say,
Ron,
oh, sorry there.
uh, so yeah, Ron, I just kind of like had a follow-up question. Generally, how do you go about looking at the support for implementing telematics within this whole process?
Is that for me?
Yes, for Ron.
Uh, well, it's there are so many benefits to telematics that you know it almost sells itself now. But as far as the cost, we do have to get obviously permission to uh, install telematics, but the data, the safety benefits, uh, just looking at the forecasting, um, it's just so valuable. It almost sells itself. Um, but how to get support for it? Um, there's good support out there. The operators will give you some resistance because they don't want to be tracked, but that's what the bargaining unit and the policy updates are for, to address um, those those types of discussions. But once drivers and operators have it, I've seen way more cases where it works in the employee or the operator's favor, than it worked against them. And I think they start to see that over time. And so it's really not hard to get support for it. It's just managing how to get the cost approved, and it will pay for itself.
I would add that it's also been really beneficial for our safety team, for any sort of like vehicle accidents. And we do a safety maturity index, and they use the telematics data in calculating that.
Jerry, would you like to add anything?
Really, no, the other presenters, I think, covered it. But stepping back to the cost really quick, one thing that I think it's important to keep in mind too is rarely do we see where the cost of doing the study is more than the savings that we find. So there's kind of like a holistic aspect to keep in mind too. So yeah, And I guess maybe I will add really quickly too on getting the buy-in. Telematics, the different systems, they all allow you to have different security settings, and if you don't want to include personal information on there, you just have some basic vehicle stuff, you can set that setting too. So I know sometimes there can be some pushback in terms of like watching what people are doing and that sort of thing, and really that's very workable.
Okay, well, yeah, we're approaching that 3:30 hour. I'm going to kind of share my screen one more time, or basically for the last remainder of the slides, for everyone to see our conference that we have, the Sustainable Fleet Technology Conference. Uh, Currently, we're in early bird registration mode, so we definitely encourage everyone to register before July 10th to go ahead and get a good discounted rate. You can go on to stateexpo.com for more details on that. Also, here's a look at the webinar schedule for the rest of the year, 2026. Our next webinar is July the 16th, which will look at preparing for natural disasters. And go on to go.ncsu.edu/SFT webinars to look at more of that description as well as for the upcoming webinars. And we're always looking for exhibitors, sponsors for our conference, but particularly sponsors for our webinar series as well. So if you feel inclined to do so, feel free to reach out to us as well for sponsoring the webinar. And other than that, I will go ahead and wrap it up. Definitely want to thank the presenters again for wonderful presentation. If you have any questions, feel free to reach out to them. I believe the webinar recording will be available. And with that, we'll go ahead and end the webinar. Thank you all for taking time out to listen with us today, and look forward to speaking with everyone soon.
Thank you.
Thank you, Ulrich. I just wanted to conclude by saying thank you to Ulrich. Thank you, Jared, Katie, and Ronald for a great presentation. And thank you all for joining us today. If you think of any questions after we wrap up, please feel free to reach out to to the NAFA team at info@nafa.org. Also be looking out for your email. You will be receiving the slideshow as well as the recording. So this concludes today's webinar. Thank you again and have a wonderful rest of your day.
Thanks
Thank
everyone.
you.
Bye.